Welcome, one and all. Coach Jay, Section 7.1. Hope you're having a fantastic day. I've kind of merged Section 7.1 with 7.2, and I'd love to just get started with that. Make sure we kind of go through some of these questions together. The Level 7 homework, which was 7.1b homework that we did in class, wanted to make sure I addressed a couple of questions that some of you had in regards to how we find the intersection on a graphing calculator, how do we solve a word problem, and many other things. And so I want to make sure I kind of went into this a little bit, made sure we kind of addressed a couple questions you had, and then kind of go from there. So before we get to this, because all of these, and I kind of rearranged these, kind of rearranged these here in terms of where all these were, but you kind of see here the level 7 problems, very similar to this. But the one I wanted to look at was this break-even analysis, and I wanted to give myself some room, so that's why I adjusted this. So let's go right straight into it. It says this: a small fast food restaurant invests $5,000 to produce a new food item that will sell for $349. Each item can be produced for $216. Well, one of the important things to remember is that anytime I go to a problem or I attack a problem like this, I want to make sure that I know what the overall goal of this is here. Well, because it's a break-even analysis, we're trying to see how many items of fast food that we can sell in order to get break-even from what we initially invested. Well, let's start off by first identifying that when I do have, let's just say we have McDonald's here, okay? So I got my McDonald's, perfect. There's a couple things that are occurring. First off, I have a cost that is going out of my business, right? This is going out. And then hopefully the food's good, right? Hopefully we have income that is coming in. So really we have two equations that are happening. We have a cost and we have an income. So what we can do is first set up our C, which is our cost, and second, we can set up our income, which would be I. So let's talk about our cost first. First off, we know that we initially invest $5,000. So with this initial cost, we have $5,000, which is a flat rate, in order to be invested to produce this new food item. I know that I will also sell it for $349, but notice the $349 is not necessarily my cost. It's the amount that I'm going to charge other people to buy. Now we know that each item can be produced for $216, so we know that it also not only costs us $5,000, but it costs us 2.16 times X, right? Or $2.16 of X. And again, what happens now is that this is now our C, or our cost. Okay, that's our total C. Now let's talk about our income. Our income relates to being sold for $349. So we want to sell it for $349X. Again, this is the amount of income that's coming in. So we have our cost, which is C, and we have our I, which is the income coming in. The question is when does this balance out? When do we break even? Another way to put this is, when do we start becoming profitable? At what number of food item do we start becoming profitable? So at this point, what we're going to do is we're going to set this up to where we set up the C equal to my I. So I've got 5,000 plus 2.16x equals 3.49x. Well, let's subtract 2.16. I'm trying right now to isolate that x on both sides here to get 1.33x, and this equals our 5,000. Let's divide by 1.33 on both sides to where 5,000 now divided by 1.33 gets us a specific value of 3,759.40. Okay? And make sure I did that right. 33. Awesome. So what we're saying is on the, really, let's round up, on the 3,760th one, which is the fast food item, we start becoming now profitable within our business in terms of the amount of items that we have to sell. So the question becomes, what if now I say, okay, I'm not just wanting to be profitable. I want to know at what food item I'm now going to be at $8,500, or to make a profit of $8,500. Well, remember that it cost us $5,000, right? Remember that. Well, in this case, because I want to add $8,500 to the amount I want to make, we just adjust the $5,000 from the $5,000 I initially invested, and I add the $8,500, which is what I want to make off of this food item. And now what we have is now we just replace the $5,000 with the $13,500. So we take $13,500, divide that by 1.33. We solve for that, and once we do that, over here, this second one, so this is A right here. Our B version, when adjusting the 5,000 to 13,500, I get 10,100. I'm sorry, this isn't money because we're talking about food items. At the 10,150 first, I can expect that to be, because I rounded up there, I would expect that to be at about $8,500 in net profit there. Okay, and that's how we would do this one. Another one I wanted to kind of look at was one like level 4 down here. Now, you did not have to do this one, so I don't want you to think that you did. But one of those things that I'm hearing a lot of is these decimals or fractions. The easiest thing to do in any of these cases is to, hold on just a second.
Hey, is this the toilet you were calling about, right? Okay, because it says soccer or something on your, when it comes in, it says soccer between the boys, locker room and something like that.
Oh, okay. I probably had done it one time. It's probably just saved there. But yeah, it's
Okay,
just this
all right.
one right here.
Thanks, sir.
You're very welcome.
All right.
Sorry about that, y'all. We got a toilet issue in the Spartan Hall. Always something. All right, so what I could do is get rid of this decimal that's here by just simply multiplying this first value by 10. And what that does is if I do it to each of these, it's got to go to all three values, right? So I adjust that to where now I have 15x plus 8y equals 23. Because again, what did I do? I moved it to the right by one decimal. Same thing holds true down here. I could also multiply this one by 10 and make this 3x minus 2y equals 1. Just adjusted it by 1. I could then do a couple of things. This could also, this actually says it's substitution. I could substitute. That'd be kind of a mess. I could also eliminate. What I'm going to do here is I'm going to eliminate by multiplying this by 4. So I'm going to rewrite the second equation when it's multiplied by 4. So I'm going to distribute this here, kind of bring back 7.2. 7.1 is more substitution, and this is more 7.2 right here. Okay, so just a heads up there. So now this is left with 12x minus 8y equals 4. And so this is now gone, that second equation. And now we're just going to combine these together. So 15x plus 12x is 27x. Negative 8y plus 8y is 0 equals 4 and 23 equals 27. So I divide by 27, divide by 27. X is now equal to a value of 1. So plug it back in. We can plug it back to the original, or it really doesn't matter. We'll do it to the original, which is right here. So 3 times 1 minus 2y equals 1. So we get 3 minus 2y equals 1. Subtract by 3, subtract by 3. Negative 2y equals negative 2. So I divide by negative 2, and y would be equal to, I got a value of 1. You could check that by plugging it in. 15 times 1 is 15, plus 8 times 1 is 8, and that does equal 23. So I could check it off by going from there. So I would write this as 1, 1 as the coordinate point where these two graphs would intersect. Okay. All righty, let's go to, I do want to do this one. Let's back up here. The only other one I really wanted to hit on was, let's do, no, I don't want that one. Let's go down here, okay? Now, anytime we come to a problem where we're trying to graph these, we want to isolate what y is. So for the first one, get this statistic stuff out. You'll notice that e to the x would be my first specific value because it's y equals. Now, the second one, y is not isolated. Well, we can do that by adding y to both sides and saying that x plus 1 equals y. And so y2 would be this one on my calculator, where y1 would be that part. So y2, we're going to plug in x plus 1 right here. Okay. Press graph. And if I can't see it, I can always go to zoom. I could try standard. There's always different options that you can kind of take and use here. But we'll go to second trace, which is that, you see that little CALC. That's why we hit the second to get up here. Then we go to intersect. We want to make sure we're on the blue curve, or maybe the red curve, doesn't matter, just one curve first. I love the colored one because it allows me to see that I do the blue one first, then the red one. And then the guess, I'm guessing it's going to be about right up yonder here, to where once I press enter for the last time, I get this weird funky answer of negative 3.11 e to the negative 7th, which if I did that in scientific notation, that would be negative 0.000000311, which is very close to 0. Very, very close to 0, especially if I zoomed in right here, you would see that. And then 0.99997 is very close to 1. So we would say that our solution, by using the calculator, would be 0, comma 1. Make sure your x comes first. You don't want to do what I just did and get that incorrect, okay? All right, this one over here, just a heads up down here, if I were to solve this one, a good way to solve this would be to multiply by 100 to get rid of these decimals. So this would be, if I multiplied by 100, I'd have to do it to all three of these, right? Can't just do it to one. Got to give love to all of them. So we'd have 2x minus 5y, because we'd move the decimal twice with a when we multiply by 100. And that equals negative 38. The second one would be 3x plus 4y equals 104. And we can then solve this by solving. One of the things you could do, you could isolate either x or y by substituting. It might be easier on this one to maybe, like on the top, multiply by 4 to use elimination. And on the bottom, we multiply by 5. So then we have 8x minus 20y equals negative 152. And on the bottom, we get 15x plus 20y equals 520. Y's cancel, so we get 23x equals, make sure, 468, is that right? 8, 6, 468, yeah. So 468, I think that's positive. I'm just making sure. So 468 divided by 23. Make sure. So we got 8x minus 20y That's good. Make sure I did all these in my head, so I'm trying to come back with my calculator here. 520. Oh, 368, my fault. This should be it. And then divided by 23, that's why. And x equals now 16, right? You could get a fraction, but I figured that I probably wouldn't in this case. Then I could plug 16 back in for x there, right? We could plug it back in. So 3 times 16, 104 minus 48. And divided by 4. And I got y is equal to 14. So in both of these, this is a good one where we utilize elimination and then go from there. And then our final thing in the podcast, notice that this has one solution based on my graph. Sometimes we could get something like over here where we could get like 0 equals 7. That isn't true because our variables, both x's and y's, would cancel. So that's why we would have actually no solution in this case, because they do not intersect. In some of these examples, over here on this third one, when I multiply the top by 2, we get x's and y's cancel, but so does my solutions on the right side, which means that this is the same equation. That's why they're on top of each other, and that's why we would have all solutions here. The only one that is, okay, so this one is consistent because it has an answer. This is inconsistent because it doesn't have an answer. And with all solutions, we would say that this too is consistent, okay? Hey, I hope that was helpful for you. Just wanted to make sure we went through a couple of those together. Substitution, remember we just simply, like in here, we would isolate either x or y, plugging it into the other equation and get it out and go from there. Hey, I hope this was helpful for you. Care about y'all. Let's keep getting after it.